Today I'm going to be telling you guys 3 stories. Earlier this year, there was a global electronics company. They do about $60 billion of revenue per year. And they were very excited to build their first generative AI application. Their supply chain leaders were tired of waiting on answers from their own analytics teams. They all have big analytics teams, but whenever they asked a question and they needed to make a decision very quickly, it would take a very long time for them to be able to get the answers that they wanted. And so most of us here are somewhat knowledgeable in generative AI to be able to know that there's a low-hanging fruit in the space of generative AI, which is the opportunity of being able to ask a question real time, right? And using your generative AI tool of choice to be able to generate an SQL query, right? So for example, in this case, you have a table of orders. Now, this is an oversimplification, of course, for you guys to be able to understand this. A table of orders where you've got, for every order, you know who the vendor is, and you know whether it was on time or late. And it's a simple question that they say, well, show me the proportion of vendors that were on time. Yeah? Okay. So the data scientists and that were building this application, they went ahead, tested this one, created a bunch of SQL queries, and they get this output. So this is the output that they got. They got vendor A at 5%, B at 7%, and vendor C at 50%, which seems to show that vendor C needs some talking to, right? So they went ahead and deployed this application. A few days later, we get a call from one of their senior leaders who asked the same question, and they got this result. So, as we all do, we jump into conclusions, right? Picked up the phone, called vendor A, and went off on a rant. Now, vendor A has no idea what's going on, right? What do you guys think happened in this case? It seems like it should be pretty straightforward, right? Well, let me give you a hint. This is what the aggregate data looked like. So if you see, I can see some smiles around now. You guys can kind of see what happened, right? So on the left, what it was doing was it was taking for vendor A, the number of late orders, which was 20, divided by the total number of orders for vendor A, which was 400. Which is why you got a value of 5% on the left. But then when they ran it a different time, the query that was generated was something like this. And now it was dividing the same 20 late orders by the total number of late orders. So you see how something so simple significantly gave a different answer. And in this case, a scene of embarrassment for the supply chain leader, right? So the lesson that we learn here is that just because, generative AI inconsistency of not being able to generate the same output every time, even though you ask the exact same input. And now this is not new for many of us, but those of us that come from the area of programming and computer science, it's ingrained in our minds that if it worked one time, it should work the remaining times because I have hard-coded the logic. How else could it be? But the inherent stochasticity of generative AI pretty much, breaks that assumption, right? So this doesn't mean that we have to, completely ignore generative AI in this case. What we suggested to them was, you know what? Let the developers use this feature. Let them use this feature, come up with the SQL queries, but then feed them into a database of verified queries. But then when the business users, when the leaders want to use it, create an application for them where when they ask a question, you'd run a similarity match to the already existing questions in the database, pick an already verified query, and then generate the output. So you're still using generative AI from the developer's perspective, but the end users are now using AI, classical AI, with some sort of cosine similarity or something, but they're picking from queries that are already verified, right? So just because you can apply generative AI to run SQL queries on the fly, doesn't mean you should allow the inconsistencies of generative AI to impact your decisions that you make. Right? But one of the nice things that came out of this after we did this exercise was that the business leaders, their trust in the system and their trust with the data scientists increased after we brought them into the loop and said, well, this is what happened. We're sorry. But going forward, you're always going to be getting verified queries from now on. And that increase in trust was a significant byproduct for the future performance of that company. And then increase the collaboration significantly, right? With that, let me go over to story number 2. Now, speaking of collaboration, in my role as faculty here at the University of Texas, specifically in data science, we collaborate across the university quite a bit. Right. Recently I was with the faculty of ophthalmology, and over lunch they were telling me about how much of a pain it is for them when they go through applications for residents that apply to their program. So you guys all know, right? That's how it works when a medical student wants to go and get their residency somewhere. They have to fill out these applications. It goes into a matching system, and then they get matched, right? That's the process. So this is what that application looks like, by the way. It comes from a system called SF Match. SF Match does the collection of information. That's where these students go and fill out their applications. So there's basic information, like their, what recommendation letters they're getting, what their GPA from the university GPA, what their USMLE scores are, step 1, step 2 mostly, what publications they have there on the bottom, how many publications they have, where did they publish, and then they have a personal statement that they write up. This package, by the way, is 40 pages long. Okay, and it only comes in PDF, by the way, right? Fun fact. So in addition to this, they have full letters of recommendation. And in med school, by the way, interestingly, this is something I learned recently, you don't really get a grade. You don't get you're in the, you got an A, B, C, or D. The way it works is they tell you whether you were in the bottom half of the class or the top half of the class, or maybe in the middle somewhere. And that information, by the way, guys, is hidden somewhere in the middle of this entire 40-page document, conveniently, right? So the opportunity here is, what if we could apply some sort of generative AI here to be able to read through this document, right? It can't be that hard. It's a PDF document. By the way, we would think that OCR would have, come far by now. None of the OCR tools were able to get us even 50-60% close enough. And so, yeah, we had to modify our own OCR tools, run entity extraction and things like that. And this is what we were looking for on behalf of the ophthalmology department. What is their academic performance? Okay, look at their GPA, their step scores. Then measure how well they've done in research. As we go through these applications, it's a lot of fun, by the way, just to kind of see how people try to play the system. I'd seen applicants that have 35 publications, which is almost unreal. And what's interesting is when you compare their application with other students, there's a lot of overlap, right? So it's almost like, me and my 20 friends, we each do one paper and we have 20 now authors on every paper, right? So looking at the total number of publications is not enough. You also need to know how many of them are these students, are they first authors or first 5 authors, to be able to see whether they were really, did they really do work on that research? And then this is where the softer side of things come, where you have to read through their personal statements, You also have to read through their section on what volunteering work did they do. Many of the students that apply, by the way, do a lot of voluntary work with the homeless. So providing healthcare to the homeless is a very common thing to be done. And then gauge their potential future bedside manner, right? How empathetic might they be? Now, these are all extracted from the content. So there's always a potential for bias here. But the alternative is there's humans reading these with just as much bias or more. And after doing all of this, combine that into some score. Then this score is then used to sort all of them before they get shipped off to be interviewed, right? So this is after they submit the application, before the interview, okay? So what could go wrong here? Right? It's a perfect system. Everything should work perfectly, right? As our team was working on this, as data scientists, we should be sticklers for attention to detail, right? So we plotted the scores. We just had gotten through the first 50, and we said, let's see what's happening. This is what we saw was happening with the output scores, the summary score. Okay? So now, anybody who's built box and whisker plots for any application, something doesn't look right here. Now, we're all for anomaly detection, right? Half of us here probably did some sort of anomaly detection. That's not an anomaly. That's anomalous to anomalies, right? And so we asked the team, you know what, go back in the spirit of ML Ops here at the conference, go back and trace, let's see what is happening at every candidate. Okay, and then this is what we found. So these candidates, this is how we're processing these candidates. They're not sorted in any way, right? They're coming from a random set. Does that look a little weird to you guys? What happened? The 10th candidate there had a high score, and seemingly everybody after that just did really well, right? Can anybody guess what might have been happening there? Calibration, that could have been it, yes? Now, again, many of you probably already know this, but whenever we're using GPT applications, generative AI applications in general, specifically when we were using OpenAI services, we're very proud of our ability to retain context, right? Right. So I ask a question, and then I ask another question, and that context is maintained as I go down the line. So in this case, what was happening was it was remembering context, even though we didn't want it to remember context. It could not forget candidate number 10 for some reason. Even though we had put in the measures to refresh memory, it still was doing this. And so what we ended up having to do here was, broke it up into two phases, right? First phase, we said, okay, we're going to run this candidate by candidate. And as we're running this on the OpenAI service, we're going to have to hard reset that entire service before we can run the next candidate, right? And now this is just one way to do it. There are other ways to do it as well. But that hard reset was necessary for the system to forget what it saw before it can apply to the next one. And then in phase 2, now that you've done it for every candidate, you can now assume independence better than we did before, and then calculate the percentile scores for each dimension. So there you see all the academic performance scores for every candidate. They're all independent of each other. Now you can do a percentile score to say, well, how did this candidate fare compared to all the other candidates that happened to apply the same year? Another fun fact here, when we ran it, this is the third time we're running it, by the way. When we ran it for the 2022-23 round, we noticed a drop in the academic performance, most likely because of all of them who took the step, the USMLE during COVID. And so by taking these percentile scores, you're normalizing for that. You're not penalizing anybody for it because you're comparing them against each other, right? And so now, we look at the timeline now, looks a lot more random as we would have expected, right? And then, okay, now we can breathe a sigh of relief. That's what it should look like, yeah? So just because you can batch process a bunch of content at the same time Doesn't mean you should allow the over-contextualization or any issue like that to affect your ability to make independent decisions, especially when you're evaluating candidates and students for what might be something, a life-changing event in their careers. Right? That was also in the area of healthcare. How many of you here would consider mental health as a growing area of concern, at least here in the US? Show of hands. Doesn't it seem like many of us are either dealing with it directly in our families, friends, colleagues, or indirectly in some way? And it seems to be increasing exponentially. COVID didn't help with that at all. But the problem in trying to solve that or trying to help with that is that there's never enough therapists. So there's telehealth companies that have come on, some really good ones, by the way. If you haven't seen them, 7 Cups is a really good one. Amwell is another one. There's many that are in this space and they're doing really well, but they're never enough therapists. Because these therapists these are experts who are experts in CBT therapy, DBT, which are very complex when you deal with suicidal patients. So the opportunity was, what if you could leverage one of these existing telehealth applications to then train them to be able to behave like a therapist? Now, why would you ever do this? A lot of times, when somebody is calling these lines or you're trying to use these apps, it's usually in the middle of the night or at some random time of the day. They don't schedule their anxiety, right, from 8 to 5. And when they do call, the last thing you want to happen is for that call to go to voicemail. Can you imagine what it might be like for somebody who's right at the edge and the feeling of what it might be to not even be answered? So if we were to implement something like this, right, we thought, okay, you know what? You'd be trained on specialized therapies, available 24/7, multi-language support, right, when you have people that need it in different languages. And then, it would be focused and unbiased, so there wouldn't be any issue with picking certain calls or spending more time with one patient or another. So we went ahead and built that application, and it took a few weeks for it to sort of build up momentum, but then by the 2-month mark, the users on the app was growing crazy. But at the time, we asked the team to pause for a few days at that point, and we did so patient calls were down, by the way, so they weren't calling as much now that they were using the app. Great, right? What could go wrong? Yeah? When the therapists did follow-up calls with some of these patients, this is what they found out. Patient frustration was high. And when we dug deeper, spoke to some of these patients, this is what was common. Thanks for trying, but I feel betrayed. Betrayed why? Because when I was at the edge of the line, and when I shared my feelings, and when I shared the fact that I was vulnerable, the system responded, I know how you feel. So an AI system that has no feeling is telling me it knows how I feel. And that was the last straw. Guys, none of us want to see that. Right? Whether it's personal, whether it's in your family, whether it's in your friends, you never want to see that, right? So, as an alternative, so this brings up the insensitivity of generative AI. And as an alternative, what we've suggested to the team is to do some sort of offline processing where you learn the histories of these patients and annotate that from an expert to say, where in the spectrum are they? How close are they to the end? And then you still leverage generative AI because you still have to pick up the calls. You still have to answer them in some way. You can't let it go. But once the results are offered, that still gets funneled through another therapist, but this time it doesn't have to be an expert. It could be a junior therapist who's now filtering it for the sensitivity. Again, this is one among many solutions that could be implemented here. This is still in process, by the way. And so we are not yet seeing the impacts of this. The challenge is here, we're trying to straddle between, do you not answer the call? Do you not answer them? But when you answer them, how do you do it in a sensitive way? You can leverage generative AI, but just because you can have an AI system, have the conversation on your behalf, doesn't mean you should allow it to play with somebody's emotions. Right? So with that, I'd like to conclude, guys. So there's 3 stories here we wanted to share with you guys. The work we do used to be back office. There used to be a gap between, machine learning models are being deployed, machine learning models are being built, but they're not getting deployed, or they're deployed, but they're not getting consumed, or they're getting consumed, but they're not generating business value, right? That's what we've been hearing for the last 4 or 5 years. With generative AI, it's closed that gap. It's closed that gap. You're reaching the end consumers right away. But this is an analogy I give to a lot of my students, is you think of generative AI as fertilizer that you have for your garden. You want to use the strong stuff. You want to use the stuff with nitrates. You want to use the stuff that gives you the best spring bloom. But along the way, you might hurt the fruit that you're trying to grow in the same garden. So striking that balance is very critical. We are impacting lives, literally impacting lives right now. And so it's on us to be, to up our game now and to make sure that we straddle this path, because the rest of the community is looking up at us to be able to make the right decisions. Right? Thank you very much.
Thank you so much, Dr. Iyoob. I think we have some time for questions, so please raise your hands and the mic will come to you for questions.
I want to be careful with the wording of my question, to have some grace on me, but how do you convince, or how did you guys come to the conclusion of kind of testing something that is not really proven in an environment with real people going through real problems with real consequences? I sure hope no one ended up committing suicide from a chatbot that was giving them help. In some of our industries that have very highly consequential decisions to make based on these AI models, how are you guys kind of towing the line in that respect?
Very, very, very good question. In the case, I think I heard this yesterday by one of the speakers here. In the space of healthcare specifically, even among all of the mission critical or critical applications that are out there, healthcare is as critical as it gets. There's no concept of fail fast in healthcare, right? That's not an option. So in these situations, we had to recruit candidates from among the healthcare community themselves, but not patients. And so it's the equivalent of, I don't like to say clinical trials, but it's our version of trials, where we put ourselves in that mode, and then it will never be the same as a patient. But we test it on ourselves and then see whether we are able to achieve, some level of a threshold of acceptance. And in the mental health space, we actually don't know the answer to some of those things. I would assume that if we were to build something like that, you would start with people that were remember I said you had to annotate the patients? You would pick the ones that are at the least end of that spectrum and then start with having conversations with them, not with the machine, with a human, and then see what the machine is responding and then decide whether that machine is ready to respond or not, right? But in all of these systems, guys, you cannot take the human out of the loop, right? Now, the only difference would be that you might be able to split where you need an expert in the loop versus where you might be able to live without an expert, but you still need a human of some sort in the loop.
Right. That staying with the use case of healthcare and to your point, still having humans in a loop, have humans in a loop for annotation, things like that. Some of the approaches to alleviate the situation too is the implementation of rules, guardrails, right? If you
Sorry,
think about
implementation of?
Implementation of rules, guardrails. In those scenarios. So talk to us a little bit about, scalability from that aspect, because now it seems like if you implement, things like guardrails or rules in this scenario, how scalable would these solutions really come?
Yeah, that's another good question. Guardrails in this, this is something I'd like, by the way, to share with everybody here. Well, we used to think of guardrails in the classical AI space, where we would put boundaries on what the output would be, right? You would put some boundaries, or you'd give some sort of test cases. You can't do it like you do in classical computing, but at least in machine learning, you still might be able to come up with some sort of test cases. With generative AI, it's very difficult to come up with test cases because of the inherent stochasticity of the system, right? If you fed the system with a different set of history, with a different input set, the stochasticity could still take you outside of the bounds. It doesn't matter how much of the guardrails you put. I have seen a few teams that have tried something. What they've done is every time they've found an outcome that's unacceptable, again using RLHF, they would go ahead and put more guardrails, limit the types of questions that can be asked, limit the types of answers. But I don't think that's going to scale. How many are you going to keep stopping? And every time you build the system to be smarter, there's going to be smarter questions that come to try to fight it, right? So the way to handle some of those, what we're doing in the enterprise scale, this is the work that we're doing with Kyndryl, is we are trying to separate out, like we did in story number 2, separate out the cases where you're using generative AI to actually answer questions, to actually do workloads, and then from that, identify the ones that are acceptable, that are already tested to be accurate, and then feed that into a repository of its own. It'll take time to build that, right? It does take time to build those repositories, but use generative AI to build the repository, not for the end users to use them. And then the end users are now able to interact with this repository that is already validated. Now, it's easier said than done. I know it's easier in transactional systems, but even in non-transactional, so that's the direction where most people are going.